Hello and welcome to m252 Calculus 2 here at Cañada College. My name is Lapuz. In this video we will look at checkpoint 3.28. This is coming from section 3.7, improper integrals. They want us to evaluate this integral and state whether the integral converges or diverges. Now this is an improper integral because the graph of 1 over x is, as it gets closer and closer to 0, now we're going to go from 0 to 2. And as it gets closer and closer to 0, we see that this graph or this function is unbounded. So we have an issue at x is equal to 0, and that's what makes this integral an improper integral, because it's unbounded within the limits. So what we will do is we will make it a proper integral by not having anything unbounded. So we will, instead of going all the way to 0, we will start at a, and the upper limit of 2 is fine. So this is going to go from some value a to 2 of 1 over x dx. Now to make this equal, we're going to take the limit as a approaches 0, and technically we want a approaching 0 from the positive side, so we'll put a little plus sign there. Alright, now let's just take the antiderivative here. The antiderivative 1 over x is ln x, so we'll take ln x. We'll evaluate from a to 2 with the limit as a approaches 0 happening here in the beginning, and then we'll take we'll evaluate these at this value. So limit as a approaches 0 from the positive side of ln 2 minus ln of a. Alright, now this limit here, we haven't taken the limit yet, we're about to now. And what we're going to do is we're going to try to figure out what happens as this thing goes to, as a goes to 0, what happens to ln of a. So the graph of ln of a, if we graph it, looks like this, or ln of x, y equals ln x. And what happens as a, some value of a gets closer and closer to 0, this thing goes down to negative infinity. So this thing will approach negative infinity as a approaches 0. So this will go to negative infinity, which means now we have ln2 plus infinity, and that's not going to be defined. So the fact that it goes off to infinity here says that this is going to diverge, and so the integral doesn't exist. All right, and that is our solution. And I hope that helps. Good luck.